Hello students, welcome to Aditya Academy. I am Dr. Ragini Arora. Today we are going to start second chapter of our maths book, which is polynomials. Before going to start our exercises to solve the sums, in this video we will be discussing about all the important terms and formulae which will be required in this chapter. So we start with the definition of polynomials. What is a polynomial? We have been studying this polynomial for last few classes like 8th, 9th, like an expression with one or more algebraic term. See, what is an algebraic term? Algebraic term is an expression which has a constant accompanied by with some variable. This is 2x, or you can write minus 3y. So it includes one constant. This constant is any real number that we have studied till now, and this x or y, the literals that we use in this expression are called variables, right? So we can have an expression with one variable or more variables, but this is called an algebraic term, right? So an expression with single term is called monomial. Monomial, right? An expression with two terms is called binomial. These are specific terms for expressions. An expression having three terms is called trinomial. For four terms, it's quadrinomial, and in general sense, these are called polynomials. Right? Now, these all the three examples are of the single variable. I can write like 2x square y minus 3x plus 2y minus 1. This is a quadrinomial, an expression with four terms. A quadrinomial in two variables, because here the variables used are x and y. So we can have polynomials of any kind. So these names are given to the polynomials according to the number of terms present in an expression, right? So this is a monomial, this is binomial, this is trinomial, and the general term given to all these expressions is called a polynomial. Now, next we come to the degree of a polynomial. What is the degree of a polynomial? The highest power of the variable in the expression. Highest power. Highest power means, like in this expression, we have only one variable and the highest power present is 1. If nothing is written here in the power, it means 1. And this is called, here, the highest power is also x to the power 1. So, degree is 1, right? So the degree of a polynomial is called the highest power. So we have to look for the highest power in the expression. In the second expression, we have variable t. Here we have highest power 2. In this expression, we have power 1. There is no variable, that means t raised to the power 0 is there. So 0, 1 and 2. The highest power is 2. So the degree becomes 2, right? In the third example, we have variable y. It is also an expression with a single variable. Here we can see there is no variable, means y to the power 0 is there. Y to the power 1, 2 and 3 here. So we can see that the highest power involved in this expression is 3. So the degree becomes 3. Right? So now we have special names assigned to the polynomials with a particular degree. An expression with degree 1 is called linear polynomial, right? An expression with degree 2 is called quadratic polynomial. You must have heard quadratic polynomials, quadratic equations. We will be dealing all these chapters in class 10. Next, we have degree 3. Degree 3, the expression of degree 3 are called cubic polynomials. I hope these are clear now. So, next we have a definition of zero of a polynomial. You must have heard solutions, zeros, or roots of a polynomial. So all these things mean the same. And the zero of a polynomial is defined as the value of the variable for which the polynomial becomes zero. Right? So let fx is a polynomial written as x minus 2. If we have to calculate the zero of this polynomial, you can call it zero or root of this polynomial or solution of this polynomial. So the definition says the value for which the polynomial becomes zero. So if we have to find the zeros of a polynomial, we solve it like this. We write the polynomial first, then for zeros, since we have to find the zeros, we have to equate the polynomial to zero. Right? The definition says the value of the variable. So we have to find the value of x here. X is a variable in this polynomial. So we have to find the value of x for which the polynomial becomes zero. Polynomial becomes zero means the value of the polynomial has to be equated to zero. So that means fx is equal to 0. Keeping this equal to 0, we can write x minus 2 is equal to 0. And then we get x is equal to 2. So this is the value of the variable for which this polynomial fx is equal to x minus 2 will become 0. And the value becomes x is equal to 2, which is called the root of the polynomial or the zero of the polynomial. Right? And one more thing, the number of zeros of a polynomial is equal to its degree. We had just studied that degree of a polynomial is the highest power. In this case, the highest power is 1. So this is a linear polynomial. Linear polynomial means degree is 1. So you can see that after solving this polynomial equating to 0, we got only one value of x. So the degree of this polynomial is 1 and the number of zeros is also 1. Right? So the number of zeros will be equal to the number of degree. Or you can say the number of zeros is equal to the degree of the polynomial. So in this case, we had linear polynomial, so we had only one zero. Now let us take an example of another polynomial like x square minus 3x plus 2. Right? This is a quadratic polynomial, degree 2, which is called quadratic polynomial. So here to find zeros, for zeros, fx has to be equated to 0. So x square minus 3x plus 2 is equal to 0. Now to solve this is a quadratic polynomial. We had learnt to factorize these kind of polynomials in class 8 and 9. So since this is not a perfect square, we can do the middle term split method here, right? So here our expression is x square minus 3x plus 2, right? So first of all, how do we do this? The expression should be in a standard notation. Standard notation is for quadratic polynomial, it is ax square plus bx plus c. That means you should have x square term, then x term, and then constant term. So this is already in the standard notation. In that case, we multiply the first and the last terms. That means 1x square into 2. Both are positive, so the product is positive. Here we have got 2. The product has to be 2. So we have to break 2 into its factors so that we get negative 3 on adding those two terms or those two factors. So first of all, this is your positive product. Positive product means either of the two factors of this number, the both will be positive or they both will be negative because we require a positive product. For that, both of the numbers either have to be positive or negative. And for 2, we know that factors are only 2 and 1, right? 2 and 1 is 2. If we add this positive 2 and positive 1, we get positive 3, which is not required here. We require negative 3. For that, we can say, let's say the factors are negative 2 and negative 1. So if we multiply negative 2 and negative 1, we get positive 2 as our product. So which satisfies the condition that the product of these two factors is positive 2. And if you add them, negative 2 and negative 1, we get negative 3, which should be equal to the middle term. The sum of these two factors should be equal to the middle term. So our conditions are satisfied. We got the required product as well as required sum in the middle. So we now break up the middle term. We write this as negative 2x and negative 1x. We have splitted this term into two terms with the factors satisfying that the product of these two numbers is equal to the product of first and third term, and the sum is equal to the middle term. That is why this method is called middle term split method, because we have to split the middle term into two things. Now we have got four terms. We will be taking common from the first two terms. Here we have x square and x, so we can take x common. We are left with x minus 2. In the next two terms, we have only negative 1 common. By taking that, this x becomes positive and this 2 becomes negative. Since we have taken minus sign outside, when we close this bracket, the sign of all the terms inside the bracket gets changed. After that, see, we have got two terms now. In both the terms, x minus 2 is the common factor, right? And we are left with x minus 1 in other bracket. This is equal to 0. This is the factorization of the given expression. Now, this factorization has been equated to 0 since we have to find the zeros of this polynomial. So, now taking this to that side, x minus 2 is equal to 0, we get x is equal to 2. X minus 1 is equal to 0, we get x is equal to 1. So, here we have got two zeros, right? This is the verification of this note. Number of zeros of a polynomial is equal to its degree. Here the degree was 2, so we had got 2 zeros here. Hope I am clear. For the linear polynomial, degree is 1, and equating that polynomial to 0 to find zeros, we got only one value of x. So we had only 1 zero of this polynomial. And in the second expression, we had a quadratic polynomial. Here the degree was 2. We solved it by equating it to 0. We used middle term split method here. In the quadratic, once you have to factorize it by completing the square or by middle term split method. So here we used middle term split method because this expression was not the square of a binomial, the whole square of a binomial. So we used middle term split method. And then we got two zeros. Since the degree was 2, we had got two zeros, right? Next is, we are practicing now two more questions for middle term split method, right? So first of all, we have to check the expression should be in its standard notation. That means we have standard notation of a quadratic polynomial is ax square plus bx plus c. So both of them are in actual standard notation. Now after that, you have to take the product of the first and the third term. Here you have 1x square multiplied by plus 10. You get 10x square, which is a positive number. Now, when we have a positive product, we are going to factorize it, or we are going to look for two numbers or two factors, the product of whom will be plus 10 and the sum of whom will be minus 7. So I told you, if the product is positive, both of the two numbers should be negative, or they should be positive. So we will be taking negative in this case also because we require a negative sum. Two positive numbers cannot provide us a positive sum. So now we factorize this. How can we get 10? It is 1 into 10, keeping both negative because we require negative sum. Or we can write negative 2 into negative 5. In both, these are only two factorizations of 10. Either 10 into 1 or 5 into 2. We cannot split it in more methods. So, according to this pair of factors is a suitable thing for our splitting. We need to have negative 7 in the middle term. So, if we add negative 2 and negative 5, we get negative 7. Negative 2, negative 5 added, we get negative 7. Negative 2 into negative 5, we get positive 10. So, this satisfies both of the requirements. So, we go for this splitting like negative 2x and negative 5x plus 10. We don't have to do anything about 10. We just have to split the middle term, right? Now, instead of 3 terms, we have got 4 terms in our expression. That facilitates us to take factors from the first two and the last two. In the first two, this is x square and this is 2x. Only one x is common to both. So now we are left with x in the first place and negative 2 in the second place. Okay, now the next two terms have 5 number. 5 is common to both the terms. 5 is a factor for 5x as well as 10. So I can take out 5. And since this is a negative term, I need to take minus sign outside, right? Whenever the third term is negative, you always take negative number as a common factor. So negative 5 is there. Now when I wind up this bracket, the signs of the both the terms will get changed. Like this is negative 5, this becomes positive x inside, and this 10 becomes negative 2. I have taken out 5 from here. So I'm left with negative 2 because I have taken negative 5. After this, you have got these two expressions now. In these two expressions, we can see the bracket of x minus 2 is common to both. So I can take x minus 2 common. After that, in a bracket, when this is taken out, we are left with x. And when this is taken out, we are left with negative 5. So this is the method of factorization with middle term split method, right? Let us have one more example. This is a different kind because we have a coefficient of x square other than 1. But the standard, see, we can see that the expression is in its standard form, ax square plus bx plus c. So now we take the product of the first and the third numbers, 3x square into 8, which is 24x square, right? Now again we have a positive product. Positive product means both the numbers will be positive or both will be negative. Now in that case you have to check the sum. Sum is positive means we have to take both the numbers positive, right? So now we do the factorization of 24. How can we get 24? It can be 1 into 24, 2 into 12, 3 into 8, or 4 into 6. Or then we get these numbers in the opposite manner only, 6 into 4, 8 into 3, and all this. So we have these 4 pairs in which we can factorize 24. Now, what is required in the center? In the middle term, we have positive 10. See, if you add 24 and 1, you get 25. 12 and 2, you get 14. 8 and 3, you get 11. 4 and 6, you get 10. So this is our required factorization for 24, right? So we can see that 4x into 6x, we get 24x square. And when we add positive 4x and positive 6x, we get 10x as our middle term. Now we factorize this. This is 3x square plus We can write either of these two numbers first, 6x plus 4x, and then we can write 8. We have just given a split to the middle term. So now taking out common in the first two terms, what do we have common? 3 and 6. So 3 is a common factor for both the terms. Here we have 2x and here we have 1x. So 1 can be given out by both the terms. After that, we are left with only 1x at the first place. And here we have taken out 3x, so we are left with 2. Then from the next two terms, see, this is the third term is positive, so we have to take positive sign here. These two terms have a 4 as common factor, 4 and 8. So we take 4. After taking 4, we are left with x at the first place. And after that, 8 divided by 4 gives us 2. Right? So now we have got two expressions or two terms in this expression, which have x plus 2 bracket common to both of them. So I take x plus 2 common. Then we are left with 3x plus 4 in the second bracket. Right? So this is the factorization of the second expression. See, when we will have to find zeros of these polynomials, we will have to equate them to zeros, like x plus 2. For this expression, if we have to find the zeros, I write 3x plus 4 is equal to 0. Now we can write either x plus 2 is equal to 0. Since the product of two numbers is 0, either this is 0 or 3x plus 4 is equal to 0. So we can write x is equal to minus 2 or x is equal to minus 4 by 3. So we have found two zeros of this expression. And in the first case, if I equate x minus 2, x minus 5 is equal to 0, we get x is equal to 2 or x is equal to 5 as two zeros. So this is the method of splitting the middle term and finding zeros in a quadratic polynomial. Next we have geometrical representation of zeros, right? Now what does that mean? See, if I take an example like x squared minus 3x plus 2, the one we had solved in the previous slide, x squared minus 3x plus 2 is a quadratic polynomial. After factorizing it for zeros, you have to equate this polynomial to 0. So let us see how we relate number of zeros on the number line. X squared minus 3x plus 2 is equal to 0. After factorizing, we get x minus 2, x minus 1 is equal to 0. So we get x is equal to 1 and 2. So this is the presentation of the zeros. And if we need to express this polynomial on a graph, see, this graph will be having x is equal to 1. Where is x1 and let x2? So we can plot it like, it may not be the exact presentation of this polynomial, but we can have a parabola like this. That means any curve which is cutting x-axis at 2 points, it will be having two zeros. If I take a graph like this, let us have an example. See, if I am making a curve like this, how many times it is cutting x-axis? 1, 2, 3, and 4. So this polynomial has got 4 real zeros. Right? So I want to say that the number of zeros can be found by checking into a graph how many times it is cutting x-axis. Here in this graph, it is cutting 4 times. So this has got 4 zeros. If I make another graph in this, like we have 1 and then 2 and then 3. Here it is touching x-axis of the 1 point, and this is second point, and this is third point. So in this case, we have 3 real zeros. So by looking at the graph, we can find the number of zeros of a polynomial. Okay, let's have one more. Like, yes, this is a straight line. Now you don't have to do anything with this is the y-axis. Don't consider this cutting into your number of zeros. You only have to look how many times this line or curve is cutting x-axis. This line is cutting x-axis exactly at 1 point. 1 point. So here we will have only 1 0. Right? This is an example of linear polynomial. Linear polynomials always gives us a straight line when they are expressed on a graph. So this is a cubic polynomial, right? This is a biquadratic. Biquadratic means a polynomial with 4 zeros. Biquadratic, right? One more thing. If we have a graph like this, a curve is presented on a graph, but it is not cutting x-axis at any point. So in that case, we can say that this has got no real zero. Since we are concerned with real numbers only, we will not be looking for the complex zeros that we will be learning in the class 11 or 12. So we are just restricted to real numbers. So by looking at this graph, since it is not cutting x-axis at any point, we can say that it has no real zeros. Right? So this we will be doing in the first equation, first exercise of our chapter. We have to find the number of zeros from a graph. Next, we have relationship of zeros with coefficients. So we just see that the standard notation of a quadratic polynomial is ax square plus bx plus c. When we have to find the zeros, we equate that polynomial to 0. So in this case, since we are looking for zeros, we have taken this in an equation form. Ax square plus bx plus c is equal to 0 is a quadratic equation. Quadratic equation. And the degree of this equation is 2. So we have 2 zeros in this case. Right? We had learned how to solve this and factorize this to find those 2 zeros. Let's say we have 2 zeros called alpha and beta. Let's say alpha and beta are 2 zeros. They are real numbers. So now we have a relationship between them. Like sum of zeros, that means if we have alpha and beta, 2 zeros of this quadratic equation, then they can be expressed as minus b by a. This is your quadratic equation. Minus b over a means the sum of zeros can be written as negative into coefficient of x. B is coefficient of x divided by coefficient of x square, which is a. We will be verifying these formulae in the next slide. Just try to learn this thing. We have 2 zeros. Then after finding those 2 zeros, we can verify that the sum of those 2 zeros can be expressed as minus b by a, where b is the coefficient of x and a is the coefficient of x square. Similarly, if alpha and beta are 2 zeros, then the product of those 2 zeros can be expressed as c by a, where c is the constant term involved in this expression, divided by coefficient of x square, which is a. So this is the formula that we have to verify in any quadratic polynomial. So first we have to find the zeros by equating it to 0. Then we need to verify these two relationships in any case. Let us practice this. Here we have x squared minus 7x plus 10. Verification of relationship of zeros with coefficients of the polynomial. So we start for this. For zeros, fx is equal to 0. This is our polynomial. So we can write x square implies that x square minus 7x plus 10 is equal to 0. Now try this with middle term split method. We had practiced the same sum in the second or third slide. So I will not be solving it here. We get x squared minus 2x minus 5x plus 10, right? So by this, we have take out x common. We have x minus 2, here negative 5 and x minus 2. So x minus 2 into x minus 5 is the factorization of this polynomial. And for zeros, we get the values of x as 2 and 5. Right? This is a quadratic expression. We got two zeros. We can take either of them as alpha or the other one as beta. We can take 5 as alpha or 2 as beta. Doesn't matter. So the two zeros are 2 and 5. Now we have to do the verification. In verification, we have alpha plus beta. That is the sum of zeros is equal to, here it is 2 plus 5, which is 7. Right? And now we have to check whether this is equal to minus b by a or not. What is b here? B is negative 7. B is negative 7. So I write b. What is a? A is nothing but 1. So I write 1 here. So now you can see that I have just put this value in the form that we had to prove. It is minus b by a. Minus b by a means b is negative 7. A is 1. I have put minus here. Now by solving this, you can see that negative 7 becomes positive 7 divided by 1 is 7 itself. So yes, we can write the sum of these two zeros or roots as minus b by a, which is equal to minus of coefficient of x upon coefficient of x squared. So this is our first part of verification. Now we need to verify the product of these two zeros. Product of two zeros is 2 multiplied by 5. That is 10. Now see, if I write this as 10 over 1. 10 over 1 means 10 itself. So 10 over 1 can be written as c by a. Right? We can see c is 10 here. This is c. Compare this with this, ax square plus bx plus c. So the constant term in this expression is 10 and we have this c by a, which is constant term over coefficient of x square. Right? So we will be doing this verification in this chapter. So we have practiced almost all the things in this. So I hope all the important things we have discussed, middle term split, we have practiced in this slide. And so now we will be solving our questions in the next videos. I hope the important terms are clear and you liked watching this video. Thank you for watching and please do not forget to like, subscribe and share it. Thank you.